All right, so this is practice 1. So this is going to teach you how to do the math part for the series circuits. Okay, so this one I'll kind of go through in pretty much detail, and then the rest of them will be a little bit faster. All right, so the first thing you want to do is read the problem. So it says fill in each circle with the appropriate voltage at that point. Fill in the rectangle with the current. The bulbs have the same resistance, okay? So this is just like the schematics that you've been looking at in physics classroom and the simulation. So the first thing we're going to do is go ahead and draw a schematic. Whoops, okay? So we're going to have the battery right there, okay? And then we're going to go ahead and draw some of these circles. Now, it doesn't really matter how many you draw, right? You don't have to draw all the ones that it shows here, okay, but you can. You'll see what I mean in a minute, okay? All right, instead of a light bulb, I'm just going to draw everything like a resistor. Okay, I'm going to put another voltage circle there, another resistor, another voltage circle. Okay, then coming out of the battery, I'm always going to want to have a voltage circle there. And then I'm going to go ahead and put my ammeter down here, okay? All right, so let's see what else it's giving us. The bulbs have the same resistance, but it's not given, okay? So let's see what else we can fill in here. All right. So around the battery, you're always going to have 0 volts at the bottom of the battery. Okay. And then here we can see that this is a 9-volt battery. Okay. Because they're showing us that there's 9 volts at the top. All right. So the total voltage, which I'll fill into this table down here, is 9 volts. Right? Because that's telling us here what the voltage of the battery is. Okay? Because remember, at the negative side of the battery is always going to be 0. Okay? All right. This is super key in solving these problems. That makes it much, much easier, especially if we can get to a couple of combo problems, is remember that the voltage only drops around a resistor. Okay? It does not drop in a wire or around an ammeter, right? Because an ammeter is designed to have very low resistance, so it doesn't really interfere with the circuit. Okay, so anytime you fill in one of these voltage circles, you want to continue that around, okay, all the way until you hit a resistor. All right, same thing going this way, going from the negative side of the battery. So that's going to be 0. Remember, ammeters don't count, and that's going to be 0. Okay, so you always want to fill that in first. I would swear do that first. Okay, all right, now we don't really have anything else. We don't really know what the resistances are, okay? But if you look down here in this table, we're going to see that the total current is 0.45. All right, so now you have to think what you know about series circuits is that the current is the same everywhere, okay? So if the current is 0.45 amps, then that is what this ammeter will read. Because there's only one ammeter in the circuit, we only need one because there's only one path. All right? Okay, once we put the information, then we want to try to start solving a couple of things, all right? And we don't really know too much at this point, but we do know in a series circuit that the current is the same everywhere, okay? So the total and the current through resistor 1 and resistor 2 are going to be equal because there's only one path for this charge to travel on, okay? All right, so once we kind of put that stuff, we don't really know anything else. We need to start doing some math. All right, so you're going to use this chart, okay? And when we worked in the lab, we found out that I equals V over R, okay? If you multiply the R to both sides, you can get something that looks more like this. V equals I times R, okay? Which is a little bit easier. Whoops, how do I get rid of that? A little bit easier way to write Ohm's law, okay? So in this table, I would just recommend writing V equals I times R, okay? And then you're just going to fill out the chart, all right? Depending on your teacher, you may be required to show different amounts of work in this workspace. So whatever your teacher wants you to do, they might want you to show an example or whatever. I would recommend showing a couple of examples at first, but then after that, you're probably good to go, okay? All right, so here I can see in the first column, anytime we have 2 out of the 3 in the column, we can find the third, okay? So this top line we can do, but these bottom lines we can't because we don't have enough information yet. So we need to get some other information, okay? All right, so the first thing that I would do is we want to solve for R, okay? So if I just divide I on both sides, then I'll get R equals V over I, okay? I can see in the top line that it's 9 volts and 0.45 amps, okay, which is going to turn out to be, it's probably 20, right? Should I use a calculator anyway? Yeah, because, you know, brain dead. Yeah, 20. Okay, that's going to be 20, and remember, resistance is measured in ohms. Okay, so this is going to be 20 ohms. Okay, all right, so we're still sort of stuck, right, in this one, except for that it tells us that the bulbs have the same resistance. Okay, so in series, remember, it's going to be all of the resistors added together are going to make the total. So in this column here, if I know the total has to be 20, and I know each resistor has to be equal to each other, then I know each of these is going to be 10. Okay. All right, now I'm nearing the end because now I'm starting to fill this out. It's kind of fun. It's like a little puzzle. I think you'll really like these once you get going. Okay. Then I can look the other way to look for the voltages. So I know voltage equals current times resistance. Voltage equals current times resistance. So when I multiply 0.45 times 10, I'm going to get 4.5 volts for each of these. Okay. All right. So now the entire table is filled out. I would go ahead and check then, because I also know in series that the voltage drops have to equal to the total, right? And here it does. Okay. So when you go back into your picture, we know that this is going to be a negative 4.5 volt drop. And this is going to be a negative 4.5 volt drop. Okay. So if I start at 9 volts and I drop by 4.5, this is going to be 4.5. And then I drop by another 4.5 to get to 0. Okay, so this is all looking good. All right. Okay, so the last thing you have to do is this voltage graph. Okay, and there's kind of some differing ways to do this, but we're going to do it like this. Okay, you're going to label different parts around the circuit with letters. All right, you're always going to put A at the negative side of the battery and B at the positive side of the battery. Okay, then the only other place you really need to track it is around components where there's a voltage change, which would mean resistors. Okay, so AB, on this side of the resistor, I'm going to have C to D. And then around this resistor, I'm going to have E to F. And then I don't need one down here, right? Because the ammeter is not taking a voltage drop. It's already at 0 here. All right. So we're going to label this A, B, C, D, E, F. Okay. And we're going to track the voltage on the y-axis. All right. So the voltage at point A is 0. Okay. And then I have to get up to a voltage of 9. So I'm just going to, I'm just going to go, right, this is kind of a weird way to do it, but I'm just going to put 9 volts here and 4.5 volts in the middle, right? Because I can kind of see what's going to happen. All right, so A is 0. At position B, the voltage is 9. Okay, at position C, the voltage is still 9. Okay, so this is going to, this is going to look like this, then this. Okay, I'm going to make this a little bigger. All right. At position D, I've dropped to 4.5. At position E, it's still 4.5 because I haven't dropped any in the wire. Oh my God, I'm choking on something. Okay, and then by position F, it's going to be back to 0. All right, and then I would go ahead and put plus 9 volts minus 4.5 volts minus 4.5 volts. Okay, and so then that's what a completed problem should look like. All right, then you're going to try the rest. I'm going to make videos for each one, but please do it first. Don't just watch the video. Okay, you might need to watch one more to get the hang of it, and then you need to try them yourself. Okay.